Hey guys, today we're going to be talking about energy, and the goal by the end of this video is to understand the two major types of energy, what they are, and how to accurately measure and calculate them. So let's start off by just defining energy. What is energy? Simply put, it is the ability to do work. And when we say work in science, it's a little bit different than a regular definition. Scientifically, this means that we must have a force moving an object. Without energy, you are not able to apply a force, so you're not able to complete work. So energy is this necessary thing in order to complete work. We're going to look at two types today. We'll look at potential energy, and we'll look at kinetic energy. So let's start off with kinetic energy. Sometimes we abbreviate that as KE. Kinetic energy is the energy of objects that are in motion. So if something is moving, we say that it has kinetic energy. This depends on two things. We're going to look at an object's velocity, or its speed, and we're going to look at its mass. We can use a formula to calculate kinetic energy, and it looks like this. We're going to say that KE, kinetic energy, is equal to half mass times volume squared. And if you know a little bit about math, we can rewrite that as KE equals mv squared over 2. So you might see the formula either way, but it is the same concept. By the way, make a note somewhere to the side of this formula that your answer should be in joules. So the unit that we use for kinetic energy is joules, and you can abbreviate that with a capital J. So let's look at an example. First, we're just going to think about mass. Let's ignore the velocity for now, but if we have two objects, we'll say a 1,500 kilogram car and a bike with a mass of 500 kilograms, which do you think has more kinetic energy? Think about that formula we just described. Give it a thought, and then I'll let you know in a second. The correct answer is the 15 kilogram car. Since this object has more mass, it will have more kinetic energy. So now that we've dealt with mass, let's think about mass and velocity together. If we just look at the car and we say that at one point the car is traveling at 15 meters per second, then it comes to a stop sign and it comes to a complete stop at that stop sign. And then later it's traveling a little faster at 45 meters per second. In which situation does the car have more kinetic energy? Again, think of that formula where we're looking at mass and velocity together. The correct answer here is the car when it is moving at 45 meters per second. Since this is where it has the greatest velocity, that is where its kinetic energy will be greatest. The other type of energy we can have is called potential energy. Potential energy is energy that is stored in an object, and you can base it on three things. You can either look at its position, which is what we'll look at most of the time, and that's related to gravity. You can look at its shape, or you can look at its composition and what it's made out of. This gravitational energy depends on two things. We're going to look at mass and we're going to look at height. When thinking of potential energy, remember this. Potential energy is the energy of position. So just remember those two P's. We're looking at where an object is, and that's going to tell us something about its potential energy. So like I said, potential energy is going to depend on the mass and height of an object. And we're not talking about height of the object itself here, we're talking about height off of the ground. So how high up off the ground is that object? We can again use a formula to calculate our potential energy, or PE, and it's going to look a little simpler. All we have to do is multiply weight by height. Now remember, weight is the effect of gravity on an object's mass. So if you don't know the weight, you can multiply the mass by 9.8, and that is equal to an object's weight in newtons. This 9.8 number is the acceleration of gravity here on Earth. So gravity is pulling on everything at this acceleration here on Earth. So either weight times height or mass times gravity times height. And this, again, will give us an answer in joules, which is our energy unit. And remember, you can abbreviate that as J, capital J. So imagine this scenario. We have three different shelves. We have one all the way up here. We have one that's a little lower, and then we'll count the ground as 1, 2. Let's identify the amount of potential energy each shelf has, and we'll label it simply as no PE, less PE, or more PE. So look at the areas, think about where do you think there will be more potential energy, less, and where do you think there will be none at all. I'll give you a second to think about that. So if we look at this high shelf, that has the most height, and so we're going to call that area more potential energy. Since it's higher up off the ground, there is more potential energy. This lower shelf down here, we can say has less potential energy. It's a little closer to the ground. And down at the bottom here, when you're on the ground, there is no potential energy, gravitational potential energy at least. So we can label that as no PE. Here's another situation. We have two people on a set of stairs. We have a man over here on the right side, and over here up at the top step we have a nice lovely apple lady. If you're confused as to why a lady has an apple for a head, ask Dr. Hansen. But we want to know which has more gravitational potential energy. The answer is the apple lady. Since she is higher up off of the ground, she is going to have more potential energy. Alright, and so the last thing we're going to do is look at a few different situations and figure out whether they are an example of potential energy or kinetic energy. Let's take a look. In our first situation, we have a ball sitting on the shelf at the top of a closet. Which do you think that is? The correct answer is potential energy. Since the ball is being held at a certain height up above the ground but is not in motion, we'll call that potential. Next, we have a doormat on the floor. Which is this going to be? It's a trick. This one is neither. It has no potential energy because it is sitting on the ground, and it doesn't have any kinetic energy because it is not in motion. Our next situation, we have a ball rolling across the table. This is an example of kinetic energy. Anything in motion is said to have kinetic energy. Next, we have a cookie, and it falls from a baby's hand. Here, we actually see both types of energy. When it is still in the baby's hand, the cookie has potential energy. It's held a certain amount of height up off from the ground. But when it starts to fall and is in motion, it then has kinetic energy. In our last situation, we have an airplane flying from Dulles to Chicago. This is an example of kinetic energy because the plane is in motion. Even though it's up off of the ground, it is moving, so we say that it has kinetic energy. All right, that's it for the energy notes. If you have any questions about any of this, please ask your teacher. Bye, guys.